Guys, so let's start off the second quarter in a good note. The first quarter is behind us. Don't worry about what happened in the past. What has happened. And let's continue moving. So implicit differentiation. It should be pretty basic. It should be pretty easy. So we'll see. I guess the first thing we should probably do is just take a derivative the way we know how. So before we take it implicitly, let's talk about how we would solve it before. So I want the derivative. All right, guys, focus. So it says that I want dy dx, and I have the expression y squared equals x. So I'm going to do the explicit one first. So explicit just means, well, usually you use explicit when we're doing like sequences and stuff, a equals blah, 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 or the nth term equals blah, blah, blah. But all it means explicitly is like y equals something. So square root, y equals the square root of x. Really a plus minus, but that's fine. How will we take that derivative? Like this. So I'm going to write this as y equals x to the half. And then I'm going to write dy dx equals, and I'm just going to use the power rule, bring the half to the front, x to the negative 1/2. So that equals 1 over 2 square root of x. And I think that's it. We've been doing that a long time. And that's it. Cool or not cool? Okay. All you're going to do now, this is the same expression, guys. This is the same expression. We're just going to take the derivative immediately. But you're going to ask yourself, what am I taking the derivative with respect to what? So this wants me to find dy dx, right? The bottom is where you're taking the derivative with respect to. So that y squared, you're going to take a derivative. So that the derivative of y squared is 2y. And then you say, is that y an x? No. So you put a dy dx next to it. You can think of this as chain rule. What do you mean think of it as chain rule? Think of it like this. d dx, giant parenthesis, y, close it, squared, close. So think of it as saying, I'm taking the derivative of y with respect to x. So look, 2, leave the inside alone, and then to the power 1, and then derivative of the inside. What's the derivative of y? Focus, guys, focus. dy dx. Do you see how we can think of that as chain rule? For sure. You got it? For sure. Okay. So here we go. The derivative of y squared. 2y dy dx equals, and now I'm taking the derivative of x. What's the derivative of x? 1. All you're doing, you're done with calculus. The rest is algebra. You want to get dy dx by itself, so all you do is divide by 2y. So dy dx equals 1 over 2y. So write that down. And I know what you're saying. Maybe you are saying, Chavez, that is not the same as this expression down here. And maybe you're saying that because it says 1 over 2 with the square root of x. But it is, guys, it is. Look what y is. If you get y by itself, isn't y just the square root of x? So look, 1 over 2 square root of x if I do the sub. Do you guys see that? So it's the same. They're the same. Yay or nay? All right. So hopefully that was exciting. I could tell you guys are super excited. All right. So here it is. How do we use this? Well, before, when we had to find the slope of this circle, you would probably have to solve for y by itself and then take a derivative. But now we can just do it implicitly, just right off the bat. Take the derivative with respect to x. So look, it says find the slope. I know that I can find the slope by finding dy dx. dy dx is slope. So I'm going to take the derivative with respect to what variable? X, yeah, the one in the bottom. So what's the derivative of x squared? 2x. It's an x, leave it alone. I guess you could write dx, but dx is 1. Plus, what's the derivative of y squared? 2y, is that an x? So you put 1 next to it. Equals the derivative of 25. You're done with calculus. The rest is algebra. Move the 2x to the other side. So you have 2y dy dx equals negative 2x. Divide both sides by 2y. dy dx equals negative 2x divided by 2y. The 2's cancel out, so negative x over y. Are we okay? I make a new line. I write dy dx. I put a straight line like so. and I put the coordinate point on the little corner here. That means evaluated at, and I just plug in. So let's see, what was my x value? So -3, well, it's 3, but there's a negative in the front of that. Divided by -4. Negative divided by negative is a, so there it is. That's my slope. Done. How do we feel? Is this a lot easier than finding y equals? So you want to see how it would have looked before? You don't have to write it down. You just look how it would have looked before, guys. You would have had to have gone y equals plus minus the square root of 25 minus x squared. You don't have to write this. Then you could have written dy dx equals, bring that half to the front, plus minus 1/2, leave the inside alone, 25 minus x squared to the negative half times the chain rule, negative 2x. Look at all that work. Bam, bam. I guess it goes minus plus. We'll see which one we're going to use. X over the square root of 25 minus x squared. 3, -4 is in quadrant 3, -4, quadrant 4. So I know that in quadrant 4, my tangent slopes better be positive. So I'm going to choose the positive one, and I'm just going to plug in a 3. So dy dx at x equals 3 equals 3 over 25, 3 squared, 25 minus 9, what's that, 16? Look at that. Look at all that work. Was that a lot more work? You also had to think a little bit about it, like where are you on the circle, what quadrant, to determine which one to use, the positive or negative. And look, with implicit, you just did it. Yay or nay? Okay. You guys aren't excited about this? All right, here we go. All right, guys, focus. It says, show that the slope dy dx is defined at every point on the graph. 2y equals x squared plus sine y. So if it means defined, that means that I want to just get an expression that will always, that has the domain all real numbers. That if I have a rational function, that I don't ever get a 0 on the bottom. So let's see if that's true. I'm going to take a derivative. The derivative of 2y with respect to x. I'm taking the derivative with respect to x. What's the derivative of 2y? 2, but was it an x? dy dx equals, what's the root of x squared? 2x. Yeah, with respect to x, it's 2x. Plus, what's the root of a sine y? Cosine y, was it an x? Then dy dx was like saying the derivative of the inside, which is dy dx. We're done. You are done. All you're doing now is algebra. Bring the cosine y dy dx to the left. So 2 dy dx minus cosine y dy dx equals 2x. Factor out a dy dx. So here's me factoring out a dy dx. And I'm going to have 2 minus cosine y equals 2x. And to get the dy dx by itself, there's a product, dy dx times 2 minus cosine y. I'm going to divide by that expression, 2 minus cosine y. So I'm going to have dy dx equals 2x over 2 minus cosine y. We need a little bit of pre-calc, not a lot. We know that cosine y, the biggest cosine y is 1. And the biggest cosine y is -1. Defined for all x, y's. This will always be defined since the denominator will never be 0. 2 minus cosine y will never equal 0. So hence we just proved defined at every point. Hence defined at every point on the graph. On what graph? 2y equals whatever that graph was. X squared plus sine y. As long as it's a point on the graph, you're defined. The slope is defined. How do we feel, guys? Yeah, that's it. Good job, guys. You guys are starting off fabulous. Fabulous. All right. Find the tangent and normal to the ellipse at the point -1, 2. How do I find a tangent line? I got to find a what? Point and slope. Do I already have a point? Now all I got to do is take a derivative. We're going to have to do it implicitly because it doesn't say y equals. So just implicit. So here we go. What's the derivative of x squared? 2x minus, what rule do I got to use here? Product. So you can either choose to put the negative with the x. I'm going to choose to not, I'm going to do it like this, and then I'll distribute the negative later. So first, x times the derivative of the second. What's the derivative of y? dy dx. Plus the second, and no yawning, times the derivative of the first, which is just 1, because I'm taking the derivative with respect to x. Cool or not cool? Plus, what's the derivative of y squared? 2y dy dx equals, what's the derivative of 7? 0. You are done with calculus. The rest is algebra. Distribute the negative. 2x minus x dy dx minus y plus 2y dy dx equals 0. Whatever does not have a dy dx, I'm going to move it to the right side. So let's see. Negative x dy dx plus 2y dy dx equals y minus 2x. I usually like to have the positive first, but oh well, I know I have a negative x there. Are we still okay? What am I going to factor out? So there's me factoring out a dy dx, negative x plus 2y equals y minus 2x. What am I going to do? What am I going to do next? Negative x plus 2y, yes. It's all good, it's all good. Dy dx equals y minus 2x over negative x plus 2y. Sometimes I like to switch these and put the 2y in the front because sometimes that negative starts floating. And I need my slope at the point negative 1, 2. So I'm going to write a new line. Dy dx evaluated at the point negative 1, 2 equals, let's see, 2 minus 2 times negative 1 over negative 1 plus 2 times 2. So 2 plus 2 over 1 plus 4. I hope I didn't make any mistakes. 4 over 5. That's my slope. So, do I got space still? Yeah. So, tangent is y minus what? Y minus 2 equals 4/5 x plus 1. That's your tangent line. What about the normal line? Opposite reciprocal. So what do I say for my slope? Yep. How do we feel, guys? Shall we see how this looks on Desmos? All right, let's see how it looks. Let me go to Desmos. Desmos. Oh, it's working fast today. Okay, can you hook me up with the expression, guys? No, the expression, the original. X squared minus xy plus y squared equals 7. So here's my line. Oh, wow, look at that. Here's my ellipse. Sorry. It's an ellipse. It's not slide. Yeah, it's nice. It's nice. All right, give me my tangent. Oh, give me my point first. Negative 1, 2. Negative 1, comma 2, close. So there's my point. Can you guys see the point? All right, give me my tangent. Y minus 2 equals 4/5 x plus 1. Yep, that definitely looks like a tangent. Look at that. Give me my normal. X plus 1. Always opposite reciprocal. Yep, that definitely looks like my normal. Look at that, guys. Cool or not cool? Make sure that you guys take advantage of all this technology, guys. Verify your stuff. Make sure that a tangent's a tangent. And yeah, okay. Sorry, guys. All right, let's go to the next one. This one wants a second derivative. I believe this is this. Oh, we're almost done. 2 more. Yeah, see, we're going fast, guys. All right, so here we go. This means, bless you to the third power. This means second derivative. So here we go. You guys ready? What's the derivative of 2x cubed? Yeah, we're taking the derivative with respect to x. Minus, what's the derivative of 3y squared? Equals, what's the derivative of 8? 0. You're done. Well, you're not done with calculus completely because we're going to take another derivative in a little bit. We're done temporarily with calculus. Get dy dx by itself. I usually like to move everything to the right, but I guess you could also move the 6y dy dx to the right and turn it on positive. It's going to be positive anyways. Negative 6y dy dx equals negative 6x squared. And then I'm going to divide by negative 6y. So the negatives are going to cancel out. And I'm going to have x squared over y. Make sure that there are no mistakes. Yeah, I subtracted. And then I divided by 6y. Negative 6y. Are we okay? All right, now I'm going to take another derivative, but we're going to have to do quotient rule. Are we cool? Again, focus again. So here we go. I'm going to go slow, guys. What is quotient rule? So bottom derivative of the top minus top. What's the derivative of the bottom? All over bottom squared. Is that all they wanted? Okay. Usually you don't want to see the dy dx in there. You want to see the second derivative in terms of x and y. So all I'm going to do is plug this guy in there. And you guys will tell me if you guys want to simplify it. 2xy minus, I guess for now I'll write it like this, and then we'll x squared over y. Yeah, we'll simplify. Let's continue simplifying. Are we okay right now so far? Okay. I'm going to go slow. Here we go. Look how slow I'm going to go. I'm going to say 2xy minus x squared times x squared. X to the fourth. You're right. X to the fourth, y. And I still have this y squared in the bottom. All right. I'm going to go slow. All I did was x squared times x squared. It is x squared over 1.
Oh, okay. I was like, hey, what's going on?
All right. In the numerator, I'm going to get a common denominator, if that makes sense. So I'm going to make this a y, and I'm going to turn this into y squared. All I did was multiply by y over y. Are we okay with that? Okay. Here we go. So now I have 2xy squared minus x to the fourth all over, and then that y squared on the bottom turns to y to the third. And there it is, simplified. I did the 2x squared, y squared minus x to the fourth over y, and all that's over y. Where'd I get the what? Yeah.
Yeah, I saw that. I was like, wait, which one? Because I usually write like 5 times. Whatever.
And there it is, guys. How do we feel? Okay. All right, let's go to the last one. So this wants more experience with taking second derivative. They already tell us what the first derivative is. See, it's given to us. So here we go. Ready? We're going to go slow. The second derivative equals, the derivative of 1 is 0. What's the derivative of sine y? Cosine y. And then, yep. All right, we're not done yet. Obviously, that answer is not in there like that. Well, we're going slow. I haven't done anything crazy. Here we go. Yeah. We're going to plug in what dy dx is, guys. So here we go. cosine y, parenthesis, 1 plus sine y. Are we still okay? Distribute that cosine y. Cosine y plus cosine y sine y. Do I have that in there? What letter is it? E. Now they are more tricky than that. I thought we were going to be tricky, but it wasn't. All right. So that's it. Was that simple? Say it again.
Thank you. Like, I didn't get to finish copying it down.
All right, guys. You got a lot of time.
I'm still like your I'm still like your charger, Tom.
You got a lot of time. Let's take care of the delta, guys.
We have a delta.